Today I am going to discuss about how to convert from NFA to DFA. In the previous sessions, I have already told you that we can convert from NFA to DFA. Okay, so now how we are going to do that? I am going to discuss that concept here. Okay, so how to convert from NFA to DFA? So here I have taken one NFA here. So is that NFA or DFA? So I'm sure that it is NFA because it is not satisfying the properties what we are having in the complete system or the rules what we are having in the complete system. Because A on 0 is going to A on 1 is going to A, and A on 1 is going to B also. That should not be there in the DFA. So what we have to do, we have to convert this NFA to DFA here. So first what we have to do is we have to draw the transition table for the NFA. So for that what we have to do, A on 0 is going to where? A. Okay, so always this NFA transition table we have to use the flower braces. Okay, so A on 0 is going to A on 1 is going to where? A and also B. So I have taken it as A comma B. B on 0 is going to where? C. Okay. So I have taken it as C. B on 1 is going to where? No, it is not going to anywhere here. So B on 1 is not there. So I am going to have a null state. So then C, I am going to C on 0 is going to where? Null. C on 1 is going to where? Null state. Okay. So always in the transition table, you have to represent the starting state with the arrow mark and star with the final state. Okay. So and after this, what I am going to do, see, I am going to convert this into DFA transition table first. Okay. So one more condition or one more note is there. What is that is if NFA contains n number of states, then the maximum number of possible states in the DFA is 2 power n. Okay. So if NFA contains n states, then the maximum number of possible states in the DFA is 2 power n here. Okay. So now what I have to do, see here. First I will take the initial state, A. And after that, A on 0 is going to where? A only now. So A. And A on 1 is going to where? A and also B. Okay. So I'll combine both the states. I'll combine both the states, A, B. Then after that, what I am going to do? What is the new state I have here? A is there already, but AB is there now. So I will take that particular new state here. So that is AB. So here A on 0 is going to A and B on 0 is going to where? C. Okay. So we are going to have AC here. And after that, A on 1 is going to where? AB. B on 1 is going to where? Null state. So we'll take it as AB only. Now what is the new state we have here? AC is the new state. So AC I will take here. Okay. So A on 0 is going to where? A. C on 0 is going to where? Null state. So I'll take it as A. And A on 0 is going to where? C on 0 is going to where? A. C on 0 is going to where? Null state. And here A on 1 is going to where? AB. And C on 1 is going to where? Null state. So now any new state we have? No. Already we have A, already we have AB. So no other new states. So till we get the new states, we have to perform. Otherwise, if we don't get any new states, we can stop there itself. Okay. So now see here, which is the initial state. Always the starting state will be initial state. What is the starting state in the NFA? That will be the initial state in the DFA also. And what is the final state in the DFA? Because we are not having the same states. The same states will not be there in the DFA. What is the final state in the DFA? So what is the final state in the NFA? C. So C is there in which state here? AC. So that will be the final state. Okay. So now we have to draw the transition table for this diagram. So we have to draw the diagram for this transition table. So A on 0 is going to A on 1 is going to AB. What are the states we are having? First we have to note down that states. And then after that we have to give the input symbol. AB on 0 is going to AC. AB on 1 is going to AB itself. And AC on 1 is going to AB. AC on 0 is going to A. So now it is DFA or not? Yes, it is a DFA. So what is the note we are having in the DFA, in the conversion of NFA to DFA? If NFA contains n number of states, then the maximum number of possible states in the DFA will be 2 power n. So if the NFA is having 3 states, it is not compulsory that a DFA should also have only 3 states. Okay, it can have up to 2 power n states. That means 2 power, in this example, if the NFA is having 3 states, so here in the DFA, you can have up to 2 power 3, that is 8 states you can have. Okay. Next example I will take. So is this NFA or not? Yes, it is a NFA. So what we have to do? We have to convert this into DFA. We have to convert this into DFA. So first we have to draw the transition table for the NFA. So A on 0 is going to where? A and also B. So I have written is A comma B. And A on 1 is going to where? Nothing, null state. B on 0 is going to where? B on 0 is going to where? C. B on 1 is going to where? B. C on 0 is going to where? Null state. C on 1 is going to where? C. That is a transition table for the NFA. Now what I have to do? I have to draw the transition table for the DFA. So first initial state I will take it as A. So A on 0 is going to 2 states, A, B. So I will combine both the states. Always in the DFA, the transition table, you are going to represent with the square brackets. Whereas in the NFA, you are going to represent with the flower brackets. Okay. And then A on 1 is going to null state. So now AB and pi I am having here. Okay. So what is the new state I am having? Pi. Pi is the new state I am having here. So I have to take pi also. Pi is going to, pi on 0 is going to pi and pi on 1 is going to pi itself. And one more new state I have here, that will be AB. So what I have to do? A on 0 is going to where? AB, and B on 0 is going to where? C. So I will write it as ABC. And A on 1 is going to where? Null state. But B on 1 is going to B. So I will write it as B. So again I am having the new state ABC. So ABC on 0 is going to, A on 0 is going to AB, B on 0 is going to C, and C on 0 is going to null state. So I'll write it as ABC. And ABC on 1 is going to where? A on 1 is going to null state, B on 1 is going to B, and C on 1 is going to C. So I will write it as BC. Now B is also one more new state I am having here. So I will write it as B here. B on 0 is going to B. B on 0 is going to C and B on 1 is going to B. Now I am having BC as a new state again. So I am taking it as B on 0 is going to C. C on 0 is going to null state. So I'll write it as C. B on 1 is going to where? B. C on 1 is going to where? C. So I'll write it as BC. C on 0 is going to where? Null state. C on 1 is going to where? C. So is there any other new states here? No. So we have no other new states. Now what is the initial state? A will be the initial state. What are the final states we are having? Always you see, final states are What is the final state in the NFA? C is the final state in the NFA. Wherever you are having C, you have to mark it as a final state. So 3 final states are there. So as I already told you, any number of final states can be there in the DFA. Okay. So these are the final states we are having in the DFA. So you have to draw the diagram for that particular transition table. Okay. Suppose if you take one more example, I will take one more example for the conversion of NFA to DFA here. So is that the NFA? Yes. Q0, Q1, Q2. Is the NFA? Yes. So Q0 and A is going to where? Q0. Q0 and B is going to Q0 and also Q1. Q1 and A is going to null state. Q1 and B is going to Q2. Q2 and A is going to null state. Q2 and B is going to null state. Okay. So here now I have to convert this into DFA transition table. So initially I will take the initial state as Q0. Q0 and A is going to where? Q0. Q0 and B is going to where? Q0, Q1. What is the new state here? Q0 and Q1. So I will take it as Q0 and Q1 here. So Q0 on A is going to Q0. Q1 on A is going to null state. So I will take it as Q0 only. Now again, Q0 on B is going to where? Q0 on B is going to where? Q0, Q1. And Q1 on B is going to where? Q1 on B is going to where? Q2. So I am take it as Q0, Q1 and Q2. So now Q2. So Q0, Q1 and Q2 is the new state I am having now. So now I will take it as Q0 on A is going to Q0. Q1 on A is going to null state and Q2 on A is going to null state. So I will write it as Q0 only. And then Q0 on B is going to Q0, Q1. Q1 on B is going to Q2. And Q2 on B is going to null state. So I will take it as Q0, Q1 and Q2 here. So till now any new states we are having? No. So we'll end here up to. So what is the final state here? Q2 is the final state in the NFA. What is the final state in the DFA? Wherever you are having Q2, that will be the final state. So Q0, Q1, Q2 will be the final state. So for this transition table, you have to draw the transition diagram. So Q0, Q0, Q1, Q0, Q1, Q2. So Q0 and A is going to Q0. So I am giving a self loop. Q0 and B is going to Q0, Q1. Q0 and Q0, Q1 on A is going to Q0. Q0, Q1 on B is going to Q0, Q1, Q2. And Q0, Q1, Q2 on A is going to Q0. Q0, Q1, Q2 on B is going to Q0, Q1, Q2 only. Okay. So that is how to convert from NFA to DFA. So if you get NFA, you can easily convert that into DFA. Okay. So very easy procedure. That is, in the NFA, you have to use the square brackets in the transition table, whereas in the DFA, you have to use, in the NFA, you have to use the flower brackets, and in DFA, you are going to use the square brackets. Okay, so that is how to convert from NFA to DFA. Okay, so that's all for this session.